Okay, it's recording. Welcome back. This is the Hadoop introduction. What is Hadoop? Hadoop is that distributed framework which was first built to enable people to crunch large amounts of data at a quick pace without real costly machines. So historically, people used to use mainframe machines for their power to really crunch large data sets. But with commercial computers like desktop computers and all these blade computers, they weren't able to crunch a lot of data because it was one machine and it couldn't be horizontally scaled. The only way they could horizontally scale is actually create multiple jobs and run it on each computer and put the results together. So that was all done manually. But with the advent of Hadoop, what happened is people could distribute the work across all the computers without having to manually break them up into individual jobs and store the results in a certain spot. So the framework enabled that distributed computing much more easier than actually manually doing many more things. This was back in 2009 2008. So this was when I started doing my Hadoop training in Hadoop in 2010. That was Hadoop 2, I think so. Yeah, Hadoop 2, but Hadoop 1 was the first version of Hadoop that has been introduced. So the concepts are still the same, but a lot has changed in the architecture. So this session is only to go through the concepts of Hadoop. So what is Hadoop? Hadoop is a Apache open source framework written in Java that helps distributed processing of large data sets across clusters of computer using simple programming models. So I will just go through what are the components of it. So these are the high level components of a typical Hadoop system. So there are two parts. One is storage and the other one is compute. If you see, there are the most important two things are the storage and the compute. And these two are like the utilities of a Hadoop system. This is actually the resource framework, which is called yet another resourcing framework. So what it basically is it helps you to schedule the jobs and manage your jobs and all, and manage your resources and which job has to be scheduled into which computer. All that stuff is actually done by Yarn. And the common utilities are all the mappers and the reducer high level classes and common utilities, line splitters, all the common utilities that you need to process a file. That's under the common utilities. So these two are basically like a supporting framework, but the main components of a Hadoop are HDFS and Mapreduce. What HDFS is it's a Hadoop distributed file system, and what it basically helps you is to take your file and put it into multiple nodes and store it in a certain way so that it's accessible for you, and it's also easier for the compute to work on it. So that's the HDFS file system, the distributed file system. So apart from HDFS, now we have many more distributed file systems. One is the Gluster FS, if you have heard about it. And all the cloud storages right now are like typically like a replacement of HDFS, wherein you can put the data in certain buckets and you can actually access them. So whether you use the Amazon S3 or you use Azure Blob Store or the Google File System, all these are actually like a little bit are almost the replacements of HDFS. So typically, when I was in 2013 2014, I didn't use HDFS. I used those file systems because that was much easier to use than running a complete Hadoop system. And MapReduce is the paradigm of programming, wherein how do you run or process the file in a short amount of time, taking all the computations into consideration, mapping and reducing. So there are two phases of the MapReduce, which I would explain to you in detail. But those is a programming paradigm. So what Spark and other frameworks have done is they've simplified the MapReduce in a way. I can tell you that way. They've simplified the same paradigm of MapReduce to make it much more quicker. The typical MapReduce takes much more longer than Spark and other things because every phase has to be done and saved into the file system instead of memory. What Spark has done is it stores data in memory and it builds a graph, a computational graph, which is called a cyclic graph, which is called a DAG, and it uses that to actually do the computation. So So that's about Spark. So, but the what, how do I call, the lifeblood of all these frameworks have been MapReduce. Like a the very much the foundation for all of them. So this is what he explained about MapReduce. MapReduce is a parallel programming model of distributed applications. So this is actually first devised by Google. It's from the Google, what is that, white paper that MapReduce, and they are the connizers. Like they are the ones who came up with Google with MapReduce. So the paradigm was first used in Google for the page rank, and that's actually been open sourced and it's been adopted and used in different ways. So that's the introduction of MapReduce. And the next one is the Hadoop file system, or the Hadoop distributed file system, which is based on the Google file system, how they stored the data. And I'll explain to you in detail how this looks like how the Hadoop file system looks like and how MapReduce looks like. So I'll just go through this diagram very quickly. This is a very simplified diagram of how the Hadoop file system and Hadoop architecture looks like. So one is the name node. You can see the name node over here, right? The name node is the most important thing in an HDFS system because it keeps the mapping of where a file is and in which machine, and how many blocks it has. So that's the job of a name node. So it keeps everything in memory. Like if you see name node server, it is it has uses a lot of memory because it keeps a mapping of the file. It's and where that file is broken up into the file is broken up into different blocks, and the size of the block is 128 megs, which is typical. Nobody uses 64 megs blocks anymore. People just use 128 megs blocks, and these blocks are stored into many data nodes. Data nodes are like worker nodes. So this is like the management layer, name node, and these are like the processing layer. So if you look at the control plane and the data plane, this is the control plane and this is the data plane. So in these data nodes, what actually happens is all the data has been stored, and the jobs are also run on the same data nodes. So these data nodes are like data storage and computation. So given a file, let's suppose you have a 500 meg file. That file is broken up into like four parts, because it can be broken up into three parts. So it gets broken up into four parts, and each part is stored on each data node. And the reason it's been stored in each data node is to make sure that the distribution happens like evenly. Like it's determined by the name node how the data is being stored. So it gets stored into each data node, and there is also a replication of that data. So what happens is, what if you lose a copy of it? You can't again go back and process the same thing, right? So Hadoop, you typically keeps 3 copies of that file. You have a big file, it gets broken up into smaller parts, and those parts are saved into the data nodes, and that part is replicated 3 times and stored in another set of data nodes. So that's what this diagram shows. So the file, let's suppose the 3 parts are there. Let's assume you have 3 parts, 1, 2, and 3. So these 3 parts are stored in 3 data nodes, and it's also replicated into the other data node. So the name node here, it remembers where in this file is mapped into these data nodes, and these are the replications where these files are available. So all that information is available in the data node. So that's what this architecture typically explains. And the metadata is typically in a HDFS system, it's typically saved in a MySQL. So there's nothing really fancy about it. It just puts it into MySQL and loads it into memory. And name node also has a secondary name node. So in the initial systems, Hadoop 1, there's always a single name node, which is becoming a big bottleneck. So in the Hadoop 2 system, they have a secondary name node. So they have improved on the mistakes or whatever, the shortcomings of the architecture, and they made it more robust. So this typically just shows you one name node, but there are 2 name nodes in a typical Hadoop system. So yeah, he talks about the master-slave relationship. So this is the master, which is the controlling node, and these are all the slave nodes, which are the data nodes. So I can go into the name. let me just go into the question. Hold on. Let me go into the introduction. I'll finish the introduction and then go into the details of the name group. Let me finish explaining everything and then I'll take more questions. How about that? Okay.
Okay.
Yeah, okay. So let me finish all the simple introduction that is there, and then I'll go into the questions and everything. So this is what it explains. Data is initially broken up into 128 megs or 64 megs. So a big file, like let's suppose you have a big text file which is in terabytes, then it's broken up into 128 megs, and these blocks are stored into the data nodes. And these files are distributed across the network using in many of the cluster data nodes. That's what it says. HDFS is on top of the local file system. So there is a file system, which is your typical Unix file system, and HDFS is a layer on top of your Unix file system, because it's doing more processing, like it's managing a lot more things than your file system. So it's a layer on top of your HDFS file system, and the blocks are replicated to handle hardware failures. So that's what I explained to you, right? So why do we have replication is because these commercial computers are not robust. Like the normal machines, they can fail, so you don't lose your data. So that's the reason blocks are being replicated. And the checking the code was executed successfully. So there is a CRC code for each block, and it's been executed to make sure that the blocks have the data integrity. The data integrity of the blocks are not lost. So there are CRC codes which manage the block, which are on each block to make sure that the data integrity is not lost. Performing the sort that takes place between map and reduce. So what this means is the map and reduce jobs are usually scheduled on the block on the computers where the data blocks are. So let's suppose your data is in this node and this node. So usually the map and the reduce tasks are scheduled on these, because that's where the data is. So this is a difference between a typical processing, typical traditional processing, where data is moved to the compute, but here the compute is moved to the data. So where the data is, the compute is moved to that location. That's why it's processing faster, because the data doesn't need to be shipped and sending the sorted data to a certain computer. So that's what it says. So it's basically moving the compute to that data, and writing the debug logs of each job. So you can write a lot of debugging stuff for each job, which is done through your Mapreduce program, so which you can actually do it. So this is a very high level introduction of Hadoop. I'll go into the details of how the name node works, how the data nodes work, yarn, which is the most important thing among all of them, in my next session. So I'll stop my share and stop the recording.